Hey there, and welcome. Today, we're not going to be doing some dry math lesson. Instead, we're going to meet some of math's most peculiar and powerful characters. They're called special functions, and trust me, they don't always play by the rules.
So let me ask you something. What if mathematical functions weren't just abstract lines on a graph? What if they were characters with their own unique quirks and personalities? And that's exactly how we're going to look at these things today, like a character study of some of math's most fascinating specialists.
We're all used to those nice, smooth, predictable curves, like lines and parabolas. But the functions we're about to meet, they're different. They are specialists. Each one is built around this one, single, almost obsessive rule that makes them act in really specific and really interesting ways.
Okay, first up, let's meet our distance detective. This guy has one job and one job only, and it does it perfectly every single time. So, this detective's whole deal is measuring pure, raw distance from 0 on the number line. It could not care less about direction, positive or negative, it's all the same to this function. Whether you're standing at -5 or at +5, the distance detective tells you the same thing. You're 5 steps away from where you started. Simple as that. All right, so here's the official rulebook for our detective. It's what we call a piecewise function, which is just a fancy way of saying it has different rules for different situations. Rule 1, if a number is 0 or positive, you don't touch it. It is what it is. But rule 2, if the number is negative, you multiply it by -1 to force it to become positive. So, you take -3. The rule says you hit it with another negative sign, and boom, you get +3. 2 simple rules for one very clear mission.
And when you graph it, you really see its personality come to life. The positive side is just the simple line y equals x. But that negative side of the line, which should be heading down, well, it gets flipped right up by that rule we just talked about, creating this perfect, sharp V shape. So yeah, it'll take any number you throw at it, but it's only ever going to give you back something positive or 0.
Okay, ready for our next character? This one is even more of a specialist. Let's meet the sign spotter. This function might just have the easiest job in all of math. It could not care less about how big a number is. A million, a billion, 0.001, doesn't matter. All it wants to know is it positive, is it negative, or is it 0? That's it. Job done.
And its rulebook is just as simple, broken into 3 parts. You give it any positive number, it spits out a 1. Give it a negative number, you get a -1. And if it's exactly 0, well, you get 0. It's like a sorting machine for numbers, putting everything into one of 3 little buckets.
Now, its profile is super interesting. The graph tells the story perfectly. It's not one continuous line at all. It's broken. It's 3 separate pieces. There's a horizontal line way up at y equals 1 for all the positive numbers, another one down at y equals -1 for all the negatives, and then just a single lonely dot right at the origin for 0. So think about that. It can handle any number in the universe, but the only answers it will ever give you are -1, 0, or 1. That's it.
All right, time for our last character, and this one is all about keeping things on the level. Let's meet the floor finder.
So the floor finder's rule is super simple. You'll get this right away. Doesn't matter what number you feed it, even something like 2.99999, it's always going to round down to the nearest whole number. So yeah, 2.999 just becomes 2. It literally finds the integer floor right underneath the number.
Okay, the official MathSpeak definition can sound a bit weird at first. The greatest integer that is less than or equal to x. So what does that actually mean? Well, let's take a number like 2.7. The integers that are less than or equal to it are 2, 1, 0, -1, and so on, forever, right? And which one of those is the greatest? It's 2. So you see, it's not like the rounding you learned in school. This rule always goes down, even if you're a hair's breadth away from the next number up.
But honestly, there's a perfect analogy for this that makes it click instantly. Just think about how we talk about our age. You could be 35 years and 364 days old, and if someone asks, what do you say? You say you're 35. You are 35 right up until the very second you turn 36. That's exactly how the floor finder works.
And when you look at its profile, you see one of the coolest, most famous graphs in math, the staircase. Each little flat step is like that year you're 35. The output doesn't change. And then, boom, on your birthday, it jumps straight up to the next step. So again, it can take in any number you can think of, but it will only ever give you back a whole number, an integer. Okay, so we've met our 3 characters.
the detective, the spotter, and the floor finder. And they all seem pretty different, right? But what's the one big idea that ties them all together?
Well, the answer is that they all belong to the same family. They're all piecewise functions. This just means they're built in pieces. Instead of one rule for everything, they have different rules for different sections of the number line. It's kind of like having a team of specialists, each one handling their own little zone.
And seeing them all laid out here, side by side, it really makes their unique jobs crystal clear. You've got the distance detective with that clean V shape. Then there's the sign spotter with its weird, broken graph and that super tiny set of answers. And finally, the floor finder, building that classic staircase. They each have their own mission, their own look, but at their core, they're all built from the same powerful idea of simple, separate rules.
So what's the big takeaway here? Look, on their own, these functions might seem like, quirky little math puzzles, but in the real world, they are absolutely essential. That floor finder we just met, it's used all the time in computer graphics and programming to figure out things like which pixel to light up on your screen. So these aren't just fun characters in the story. They are fundamental tools that engineers, programmers, and scientists use every single day. And that really leaves us with a final, pretty cool thought. If these are just the simple building blocks, just imagine the incredible things we can build with them.